Question 1. Given the circumstances, Maria, a DA, notices a sudden spike in EB time with no EPU or EO bottleneck. She wants to identify which wait events are contributing most to the delay. Which approach should Maria take to best diagnose the problem? A. Query the vSCL view to find the longest running SUL statements. B. Analyze the vSystem event view to understand cumulative wait events at the system level. C. Examine the alert log for recent errors affecting performance. D. Use the hour report to compare snapshot periods and locate top wait events. Answer. Correct answer, D. Explanation. Our reports provide a comprehensive snapshot comparison of database performance over time, highlighting the top wait events contributing to DB time spikes, which is essential in diagnosing sudden performance issues without EPU or EO bottlenecks. Querying vSCL identifies long-running SUL but may not reveal systemic waits causing delays. vSystem event shows cumulative waits, but time-based granularity needed here. Alert logs are valuable for errors but not wait event analysis, hence our reports offer the best diagnostic context for this scenario. Question 2. When considering SUL execution plans, James finds that an adaptive plan changes its path mid-execution due to data volume differences. What is the fundamental benefit of adaptive plans in this situation? A. They reduce parsing overhead by caching static plans. B. They automatically adjust execution to actual runtime conditions to improve performance. C. They force the optimizer to always choose the cost-based plan initially estimated. D. They prevent any plan changes by locking the execution path before runtime. Answer. Correct answer, B. Explanation. Adaptive execution plans provide dynamic responsiveness by modifying the plan at runtime based on actual data volumes, improving efficiency and performance by avoiding suboptimal static plans. They do not reduce parsing overhead or force the optimizer to stick to initial estimates. Preventing plan changes contradicts their purpose. Adaptive plans reflect the modern approach to handle unpredictability and distribution during execution. Question 3. From the perspective of instance tuning, Roger's experiencing high latch contention in the shared pool. What is the most appropriate immediate action to reduce this contention? A. Increase the size of the buffer cache to reduce disk EO. B. Enable automatic memory management to dynamically resize the SGA components. C. Flush the shared pool frequently to clear fragmentation. D. Pin frequently used objects in the shared pool to avoid repeated reparsing. Answer. Correct answer, C. Explanation. High latch contention in the shared pool is often caused by fragmentation and repeated reparsing. Flushing the shared pool can temporarily reduce fragmentation but may cause performance hits, so it's more of a diagnostic step than a long-term solution. Increasing buffer cache affects EO, not latch contention. AM helps memory sizing but may not address latch contention directly. Pinning objects reduces reparsing overhead, but flushing shared pool addresses fragmentation, which directly relates to latch contention. Question 4. Based on the information, Alicia is tasked with validating performance changes after applying SUL tuning recommendations. Which tool should she use to measure the impact of the changes reliably? A. SUL Access Advisor to recommend new indexes. B. SUL Tuning Advisor to analyze problematic statements. C. SQL Performance Analyzer to compare execution plans before and after tuning. D. StatsBack to gather historical performance data. Answer. Correct answer, C. Explanation. SQL Performance Analyzer is designed to measure the impact of SQL tuning changes by comparing execution plans and performance before and after modifications, providing objective validation. SUL Access Advisor recommends indexes but doesn't validate changes. SQL Tuning Advisor offers recommendations but does not provide comparative analysis. StatsBack is for historical data collection but lacks focus SUL tuning impact analysis. Question 5. In the context of managing database resources, John wants to prioritize critical user sessions during peak load while limiting resources for background jobs. Which Oracle feature best facilitates this? A. Automated workload repository IA for historical performance trends. B. Database resource manager to allocate CPU and EO resources per workload. C. Shared pool tuning to reduce parsing overhead. D. SUL plan management to fix execution plans. Answer. Correct answer, B. Explanation. Database Resource Manager allows DBAS to allocate CPU and other resources between user sessions and background jobs dynamically, ensuring critical workloads receive priority during peak times. Our helps with monitoring but not resource control. Shared pool tuning optimizes parsing but doesn't manage resource allocation. SUL plan management controls execution plans, not resource prioritization. Question 6. Considering the evidence, Lydia wants to monitor active sessions in near real time to identify sessions causing performance bottlenecks. Which method should she use? A. Review the alert log to find active session warnings. B. Query active session history ASH for granular session activity. C. Use StatsBack reports for detailed session wait times. D. Examine the session wait to view historic waits. Answer. Correct answer. See explanation. StatsBack provides detailed session wait statistics but is historical and less real-time. The alert log is for errors, not session activity. The session wait shows wait info but is snapshot-based and lacks the granularity of ASH. Active session history. ASH offers near real-time, second-by-second data on active sessions, making it the preferred tool for identifying session bottlenecks. Question 7. Under the assumption that the cost-based optimizer EBO is choosing inefficient execution plans, which step should DA take first to address this? A. Use optimizer hints in SUL statements to override the plan. B. Gather fresh optimizer statistics to ensure accurate cost calculations. C. Manually rewrite SUL statements for better performance. D. Disable adaptive plans to enforce static plans. Answer. Correct answer. C. Explanation. Gathering fresh optimizer statistics is the foundational step to provide the optimizer with accurate data for plan decisions. Without updated statistics, hint or manual rewrites may not solve underlying plan inefficiencies. Overusing hints can cause maintenance issues, and disabling adaptive plans removes beneficial runtime adjustments. Manually rewriting SUL should be secondary after confirming statistics accuracy. Question 8. Taking into account a database with no licensed hour, Mark wants to collect performance data for analysis. What is the recommended approach? A. Enable SUL plan management to capture plan baselines. B. Use StatsBack to gather snapshots and generate reports. C. Review alert and trace logs for performance insights. D. Utilize ASH reports for detailed active session tracking. Answer. Correct answer. B. Explanation. StatsBack is Oracle's free alternative to IO for environments without the licensed hour option, providing snapshots and performance reports for analysis. SUL plan management handles plan stability, not data collection. Alert and trace logs provide error info but are insufficient for comprehensive performance tracking. ASH reports require licensed options tied to IO. Question 9. When faced with frequent buffer busy waits on a heavily accessed table, which action would best mitigate this issue? A. Increase the size of the PGA to improve sorting operations. B. Enable table compression to reduce physical I/O. C. Implement partitioning to reduce contention on hot blocks. D. Flush the shared pool to clear latch contention. Answer. Correct answer. C. Explanation. Partitioning divides large tables into smaller, more manageable segments, reducing contention on hot blocks that cause buffer busy waits. Increasing PGA size optimizes memory for sorts, not buffer waits. Table compression reduces storage but has limited impact on buffer contention. Flushing shared pool targets latch issues in shared pool unrelated to buffer busy waits on tables. Question 10. In light of recent developments, Sarah needs to automate tuning tasks such as statistics gathering and ADAM analysis to maintain consistent performance. Which approach aligns best with Oracle best practices? A. Schedule manual execution of SUL tuning advisor wiki. B. Enable Oracle's automated maintenance tasks to handle routine tuning. C. Rely solely on BA monitoring without automation for accuracy. D. Disable adaptive execution plans to simplify tuning processes. Answer. Correct answer. A. Explanation. Oracle's automated maintenance tasks include automatic statistics gathering and EDM analysis designed to maintain performance with minimal to BA intervention. Scheduling manual SUL tuning advisor weekly duplicates these automated efforts inefficiently. Sole reliance on DBA monitoring ignores benefits of automation. Disabling adaptive plans limits Oracle's self-tuning capabilities, counter to practices. Question 11. In a modern context of database tuning, David notices significant parsing time impacting application performance. What is the most effective way to reduce parsing overhead? A. Increase the buffer cache size to reduce disk I/O. B. Use SUL plan management to stabilize execution plans. C. Implement cursor sharing and bind variables to promote cursor reuse. D. Enable automatic workload repository hour snapshots for trend analysis. Answer. Correct answer. C. Explanation. Parsing overhead is primarily caused by repeated parsing of similar SUL statements with different literals. Using cursor sharing and bind variables encourages cursor reuse, significantly reducing parsing time. Increasing buffer cache affects I/O, not parsing. SUL plan management stabilizes plans but doesn't reduce parsing. I is for monitoring, not parsing overhead reduction. Question 12. As illustrated by recent performance reports, Samantha finds multiple sessions waiting on log file sync events during peak transaction periods. What is the underlying cause of these waits? A. Insufficient redo log buffer size causing I/O bottlenecks. B. Excessive shared pool fragmentation leading to latch contention. C. Long-running queries causing buffer busy waits. D. High CPU utilization slowing down session processing. Answer. Correct answer. B. Explanation. Log file sync way events happen when sessions wait for redo log flushes. However, the primary cause here is often shared pool fragmentation or latch contention affecting redo log management. Insufficient redo log buffer size is less common as Oracle usually manages it well. Long queries cause buffer waits and CPU issues slow processing but don't directly cause log file sync waits. Question 13. Upon closer examination, Carlos needs to interpret an execution plan with multiple nested loop joins causing performance degradation. What tuning method is most appropriate here? A. Gather optimizer statistics on involved tables to improve join estimates. B. Convert nested loops to hash joins manually by rewriting the SUL. C. Increase the size of the PGA to improve sort operations. D. Use SUL Access Advisor to recommend indexes to optimize join paths. Answer. Correct answer. D. Explanation. SUL Access Advisor analyzes SUL workload and recommends indexes or materialized views that can improve join performance, often eliminating costly nested loops. Gathering statistics is important but may not directly fix join method selection. Manual SUL writing for join types is error-prone, e.g. size affects sorting but not join method choice. Question 14. When analyzing the vSkill view, Priya notices high CPU time but low elapsed time for certain statements. What can be inferred about these SUL statements? A. They are likely performing I/O-bound operations. B. They are CPU intensive but execute quickly overall. C. They have poor execution plans causing buffer busy waits. D. They are waiting on network latency issues. Answer. Correct answer. A. Explanation. High CPU time with low elapsed time usually indicates that SULEP are intensive but completes quickly. Low elapsed time suggests minimal waiting, so they are unlikely to be I/O-bound. Poor plans typically increase elapsed time and buffer waits. Network latency affects elapsed time, not CPU time. Question 15. Considering the evidence assures tuning a database with frequent buffer busy waits due to row migration, what is the most effective way to address this problem? A. Enable table compression to reduce segment size. B. Rebuild the table or move rows to eliminate chaining and migration. C. Increase the size of the shared pool to reduce latch contention. D. Use SUL plan management to enforce consistent execution plans. Answer. Correct answer. C. Explanation. Row migration causes multiple block visits during data retrieval, leading to buffer busy waits. Rebuilding tables or moving rows physically removes migration, making this the best solution. Table compression saves space, but doesn't eliminate row migration. Increasing shared pool size targets latch contention unrelated to migration. SUL plan management affects plans, not storage layout. Question 16. In a framework of automated tuning, Ethan wants to use Oracle's tool that provides root cause analysis and recommendations based on workload snapshots. Which tool should he use? A. Automatic Database Diagnostic Monitor ADAM. E. SUL Tuning Advisor. C. SUL Access Advisor. D. StatsBack. Answer. Correct answer A. Explanation. ADAM analyzes our snapshots automatically, identifying performance bottlenecks and recommending actions. SQL Tuning Advisor focuses on SUL statement tuning. SUL Access Advisor recommends access paths and indexes. StatsBack is a manual tool for performance data collection, lacking automated analysis. Question 17. Throughout the course of monitoring, Olivia finds that the buffer cache hit ratio is consistently high, but user queries are still slow. What could explain this paradox? A. Excessive parsing causing CPU bottlenecks. B. Inefficient execution plans causing unnecessary work. C. Too small redo log buffer causing log waits. D. High latch contention in the shared pool. Answer. Correct answer. D. Explanation. A high buffer cache hit ratio indicates effective caching but does not guarantee query speed. Shared pool latch contention can cause waits that slow queries despite good caching. Excessive parsing causes CPU bottlenecks, but less likely with good cache. Redo log buffer issues cause different waits. Inefficient plans usually reduce cache hits. Question 18. Under the assumption that PGA memory is insufficient for complex joins and sorts, which monitoring view should Nathan query to confirm the issue? A. vSCL plan for execution plan details. B. vGestat for PGA memory usage statistics. C. vSystem event for system-wide wait events. D. vSession wait for session wait information. Answer. Correct answer. B. Explanation. vGestat provides real-time statistics on PGA memory usage, including allocation failures and spill-to-disk occurrences that indicate insufficient PGA memory. vScaler plan shows plan details but not memory. vSystem event and vSession wait show waits but not memory stats directly. Question 19. Taking into account Oracle's memory management features, which configuration allows automatic resizing of SGA components like buffer cache and shared pool? A. Automatic memory management M. B. Automatic shared memory management ASM. C. Manual resizing of individual components only. D. PGA aggregate target parameter. Answer. Correct answer. A. Explanation. Automatic memory management M enables Oracle to automatically resize the entire SGA, including buffer cache and shared pool, based on workload. ASM only manages SGA components but requires manual PGA tuning. Manual resizing lacks automation. PGA aggregate target managed PGA memory only. Question 20. When evaluating the merits of enabling a memory column store, which workload scenario would benefit most from this feature? A. All systems with frequent single-row updates. B. Analytical queries performing large table scans and aggregations. C. Batch processing jobs that mostly perform inserts. D. Systems experiencing latch contention in shared pool. Answer. Correct answer. B. Explanation. In memory column, store accelerates analytical queries by storing data in a columnar format optimized for scans and aggregations. ALP workloads with frequent updates benefit less due to overhead. Batch insert jobs don't gain from columnar storage. Latch contention is unrelated to in-memory. Question 21. When faced with a sudden increase in physical EO waits, Annika investigates and finds the buffer cache hit ratio remains stable. What could be the most likely cause of increased physical reads? A. Inefficient SUL causing full table scans beyond what the buffer cache can hold. B. Insufficient PGA memory leading to excessive sorting on disk. C. Fragmentation of the shared pool causing latch contention. D. High EPU, which delaying EO requests from being serviced. Answer. Correct answer. B. Explanation. A stable buffer cache hit ratio alongside increased physical read suggests that sorts or hash operations are spilling to disk due to insufficient PGA memory, causing extra EO unrelated to buffer cache effectiveness. Inefficient SUL full scans usually reduce cache hit ratio. Shared pool fragmentation and CPU issues affect other areas, not directly physical EO. Question 22. Based on the information, Michael notices the shared pool latch contention is caused by excessive hard parsing. Which approach will most effectively reduce hard parsing? A. Increase the buffer cache size to reduce disk EO. B. Implement cursor sharing and use bind variables to promote cursor reuse. C. Enable automatic memory management M to resize memory dynamically. D. Flush the shared pool regularly to clear fragmentation. Answer. Correct answer, C. Explanation. While bind variables and cursor sharing reduce hard parsing, enabling automatic memory management and dynamically adjusts memory allocation, helping reduce contention caused by insufficient shared pool size indirectly. Increasing buffer cache doesn't impact parsing. Flushing shared pool temporarily reduces fragmentation but is disruptive and provides a more systemic solution. Question 23. Given the circumstances, Lee needs to identify the SQL statements contributing most to DB time during peak load. Which dynamic performance view would provide the most immediate insights? A. vSystem event for overall wait events. B. vSCL for SUL execution statistics including EPU and elapsed times. C. vSession wait for session-specific wait events. D. vSCL plan for execution plan details. Answer. Correct answer, D. Explanation. vSCL plan provides detailed execution plans which help understand the cost and execution path of SUL statements causing performance issues. vSCL shows aggregated stats but lacks plan detail. vSystem event gives system-wide wait info, not SQL specific. vSession wait is session-focused, not aggregate SUL data. Question 24. Taking into account the nature of SQL statement processing, what is the primary function of the optimizer during the compilation phase? A. Parsing SUL and checking syntax only. B. Generating an optimal execution plan based on statistics and rules. C. Executing the SQL statement to gather runtime statistics. D. Caching the SQL statement in the shared pool. Answer. Correct answer. A. Explanation. During compilation, the optimizer primarily parsed SUL and checks syntax, preparing the statement for optimization but not yet generating a full plan. That occurs during optimization. Execution happens later. Caching happens after parsing and optimization, not during. Question 25. In response to increased latch contention, Nickel considers increasing the shared pool size. What could be a potential downside of just increasing this parameter without other actions? A. It may cause the buffer cache hit ratio to drop. B. It could lead to increased CPU usage due to more memory scanning. C. It might cause longer garbage collection pauses in the shared pool. D. It will force all sessions to share the same execution plan. Answer. Correct answer, B. Explanation. Increasing shared pool size excessively can increase CPU overhead due to larger memory areas to scan during operations like latch acquisition. It does not directly affect buffer cache hit ratio or garbage collection pauses, which are related to Java or other components. Execution plan sharing is unrelated to shared pool size. Question 26. During a performance baseline comparison, Priya observes that average active sessions increased significantly, but average wait times did not rise proportionally. What is the most plausible interpretation? A. The workload has increased, but wait event severity remains controlled. B. The buffer cache hit ratio is low, causing more physical reads, so CPU is saturated, causing sessions to wait on CPU time. D. Network latency is causing session delays outside the database. Answer. Correct answer, C. Explanation. An increase in active sessions without a proportional rise in wait times often indicates CPU saturation as sessions queue or CPU rather than waiting on other resources. Buffer cache hit ratio affects EO waits. Network latency affects elapsed time, not database CPU usage. Controlled wait severity contradicts CPU saturation. Question 27. While examining an hour report, Jason notes that DB file sequential read wait events are high. What does this wait event typically indicate? A. Waiting for redo log buffer flushes. B. Waiting for single block reads, often due to index access or small queries. C. Contention on the shared pool latches. D. Large full table scans causing multi-block reads. Answer. Correct answer. B. Explanation. DB file sequential read indicates waits for single block reads, commonly occurring during index lookups or queries accessing specific rows. Redo log flushes correspond to log file sync waits. Shared pool contention has different wait events. Large full table scans produce a DB file scattered read waits. Question 20. The primary reason Adam configures baselines and alert thresholds in his Oracle environment is to A. Automatically fix SQL plans when performance degrades. B. Establish a normal performance profile and detect deviations promptly. C. Prevent users from running expensive queries. D. Force execution plans to remain static regardless of data changes. Answer. Correct answer. C. Explanation. Baselines and alert thresholds help establish normal performance profiles and notify DBAS when deviations occur, allowing proactive tuning. They do not automatically fix SQL plans or block users from running queries. Forcing static plans is handled by SQL plan management, not baselines. Question 29. Which of the following is the best practice when using optimizer hints to influence execution plans? A. Apply hints universally to all queries to standardize plans. B. Use hints sparingly and only after thorough testing due to plan maintenance complexity. C. Rely on hints as the first step before gathering statistics. D. Disable the cost-based optimizer when using hints. Answer. Correct answer. A. Explanation. Optimizer hints should be used sparingly and carefully because they can lead to brittle plans and maintenance overhead. Applying hints universally can cause more harm than good. Statistics gathering is fundamental and should not be skipped. Disabling CPO validates the core optimizer benefits. Question 30. From the perspective of minimizing the cost of SQL operations, what is the recommended approach to manage row chaining and migration? A. Shrink segments regularly to compact data and reduce chaining. B. Increase PGA size to buffer more data in memory. C. Enable automatic memory management to optimize buffer cache. D. Use SQL plan management to capture stable execution plans. Answer. Correct answer. D. Explanation. Shrinking segments is the recommended way to reduce row chaining and migration, improving EO efficiency. Increasing PGA or AM affects memory management, not physical row layout. SQL plan management manages execution plans, not storage structures or chaining issues.